Rankin here. This is video number 7, a little bit about the machine timing. The last time, in video number 6, we installed this timing light here, and in order to see when our coils were firing, and they should fire pretty close to this virtual south, which we marked between each magnet set. So what I've done is we went through and let's get this out of here. We went through and we tested all 5 coils, and in the internal mode, which they trigger off of the winding on the coil, and then the external mode we trigger off of the computer right here. Okay, so all of the connections for the external mode are disconnected from the coil packs except for one right here, and that's the coil we'll be working with. So what I noticed is that currently we're triggering with a Hall effect sensor, which you can barely see. You can see the magnetic wheel here, and then the sensor that senses the presence of the magnet is down here. So looking at the drawing, what we have is we have our magnetic wheel. Each has the North Pole magnets on them. And we have our Hall effect switch here. When the magnet passes, it turns on the Hall effect switch. The computer senses it, turns on the solid state relay. The solid state relay sends a pulse to the driver board, and then the driver board, of course, pulses the coils. So the magnetic sensor is not very good in this case for this application. So what I found out is, let's fire this thing up. Let's turn on the power here, and we'll give this a spin. Okay, now looking at the timing light. Now we get a couple marks right there, but those will go away. But you can see this gold core of the coil, and you can see where the timing marks are. The black mark indicates the center of the coil. So if we watch, you can see the timing mark as the motor comes up to speed, moves over, and is firing pretty close to the center of the coil right now. And our lines are lined up, so it's firing at the center of the coil. So now if we switch this over to the computer control, which will flip our switch up here to external, then what we have is the timing marks are, we have multiple timing marks. What that means is that the magnetic timing wheel, which this is similar to what it looks like. We got the magnet, and then the Hall effect sensor. It senses when the magnet, goes past the sensor. The problem is that each one of these magnets aren't identical. So the magnetic field of one magnet might be stronger or less strong than the magnetic field of the next magnet. I didn't push that in all the way in because they're hard to get out. So we're going to change that, and we're going to do away with that, and we're going to go to the optical sensor, which is right here. One side has a little transmitter light on it. The other side has a receiver transistor. So this optical sensor will go between the wheel like that. So when the slot passes through, it allows the light to shine through to the optical sensor, and then the optical sensor sends a signal to the computer. Okay, so that being said, we'll be able to adjust. We're going to switch it back over. We'll be able to adjust with the computer where we want it to fire. Now I just switched it back over to the internal coil trigger winding, and you can see where it's firing is pretty close to the center of the coil. So just a heads up on that, switched it back over to the external sensor. So that being said, I just wanted to let everybody know what I found out in this build with the different types of sensors that are used to fire the coils. So, as usual, I keep my videos short, no muss, no fuss. I'll show you once we get the the optical sensor installed. We'll take a look at that. So, have a great day. Ranking out.